So let's look at some of the code. First we'll look at sequence types: string, list, and tuple. So I put a link here to the documentation. This is the official Python documentation. I encourage you to check that out. If you have any questions or you want more detail on any of these items, just look at the documentation link here. So first is indexing. We can access any item in a sequence by using its index. We put that index inside square brackets, and indexing starts with 0. The first element is always 0. So the fourth element is going to be index 3. So here we have a string frog. It has 4 letters in it. If we want the fourth element, which is G, we print out x of 3. That gives us the G, as you can see in the output here. If we have a list of pig, cow, and horse, these are strings, we can print out x of 1, and that's going to give us cow. And again, it's just square brackets. And a tuple with 4 names in it, and if we want the very first name, we print out x of 0 with the 0 in square brackets, and that gives us Kevin. So that's indexing. Now let's look at slicing. We can slice out substrings, sublists, or subtuples using indexes. So the way indexing works is you put inside the square brackets separated by colons 3 possible parameters. So we can put a start, an end plus 1, and a step. And I'll show you what each of these means. So let's just use a string for this example. Computer, the word computer. Again, the C is index 0. So here we're going to print out x of 1 to 4. So since we didn't put a third parameter, that means the step is assumed to be 1. That's the default step. So when we put 1, that means the O. And that is inclusive. The from is, or the start is always inclusive. The end is non-inclusive. So if we look at item number 4, that's the U, that's the 5th item. It's non-inclusive. So it's really just going to get OMP for us. And when we look at the result, it prints out OMP. Now here's an example using a step. So we print out x of 1 to 6. Again, we're going to start at the O because the 1 is inclusive. And we're going to go up to 6, which is the E, but it's non-inclusive. And we're going to do it in a step of 2. So in other words, we're going to get the O, the P, and the T. And that's what we print out, OPT. So it takes every other item when we have a step of 2. Next, we're going to not put a end plus 1. We're just going to leave an open colon there. And what happens is when we put the open colon, 3 colon nothing, basically the default is end of string. So everything from the third item on. So here the third item is P, because we start counting at 0. The third item is P, and we get everything from P onward, P-U-T-E-R. So if you don't know how long a string is, or you just want to get all of the remaining elements, skip the first three items or something, you use an open colon. Next, we're not going to declare a start. So we can skip the start by just putting colon 5. So in other words, our default is we're going to start from the beginning of the string. We're going to get up to the 6th item because the 5 is non-inclusive. So COMPU. And you can see our result here is COMPU. So you can see if you don't declare a start, the start defaults to the beginning. And if you don't declare an end, the end defaults to the end. And if you don't declare a step, the step defaults to 1. So that's basically what's happening here. So let's look at a negative index. So if we print out just a negative index, -1, that counts from the right side of the string. So here we want the very last item in the string. We put -1, we get the R, the last element. And then here we get the last 3 items. So we put a -3 as the from and to the end of the string. So that gives us TER. That gives us the last 3 elements. And then if we want to get everything except the last 2 elements of the string, we leave the start blank. So we get everything from the beginning up until the last 2 items. So that is how slicing works. And it works exactly the same as we just covered for this string example. It works exactly the same on lists and tuples. Now let's look at adding and concatenating. So we can combine two sequences of the same type using the plus sign. Let's look at a string example first. We want to combine horse and shoe, and we just print X. So we see the result is horseshoe. If we have two separate lists and we want to merge those two lists together, we can use a plus sign. And when we print that, we get a single list with 3 elements in it. And in the case of tuples, if we have two separate tuples and we print the result, we get a single tuple with 4 elements in it. Now it's important to note here, for the second one to be considered a tuple, we have to include a comma here. If we don't have that comma, it's just a string in parentheses. If we include this comma, that tells Python that this is actually a tuple. We can use the multiplying function to multiply a sequence using the asterisk. In a string example, if we want to print bug 3 times, we just do bug times 3 and then print. And you can see the result here is bug, bug, bug. And the same with a list. We have a list 8, 5, and we want to multiply that by 3. What we get is 8, 5, 8, 5, 8, 5. So we're not actually multiplying the elements by 3, we're multiplying the list by 3. And then the same with tuple. We can multiply a tuple by 3, and then we get basically a triplicate of that tuple. Now let's look at testing membership. We can test whether an item is in or not in a sequence. These are really easy, it's almost English keywords in Python. They made it so simple. So with a string, let's say we have a string called bug and we want to check if the letter U is in our string. We just say U in X, and that's going to give us a Boolean result, true or false. In this case, U is in X, so it returns true. And now we have a list, pig, cow, and horse. If we print cow not in Y, it's going to print false because cow is in Y. And for a tuple example, we have a tuple here with 4 names. And if we print one of those names in Z, we get true because it is in Z. So it's really easy to check membership using in or not in. If we want to iterate through the items in a sequence, we can say for item in X. An item can be any variable name you want. It can be for number in X or whatever you like. Here I just used a variable name item. Print item. If you want both the index and the item, here we have a list with 7, 8, and 3 in it. We say index, comma, item in enumerate X. The enumerate is going to return both an index and an item. So actually, again, these variable names are arbitrary. The first one is going to be the index. The second one is going to be the item itself. So you can name them whatever variable name you like, but you can get both the index and the item using the enumerate function. And then we have access to both the index and the item, as you can see the results. If you want to get the count or the number of items in a sequence, you can just use the len function. So in the string example, we have bug, we get len of x 3. This list, we have 3 items in the list, so we print len of y, we get 3. In our tuple, the len of z is 4. To find the minimum item, Python checks this lexicographically, which means the smallest on the ASCII scale. So you can use the minimum function on either alpha or numeric types, but you cannot mix alpha and numeric types into a list or a tuple. You'll get an error. So here in our string example, we print the min of x, we get the smallest letter, which is b. And in the list, we print the minimum of y, which is cow, because it basically is going to compare the first letter first, and C, it comes first alphabetically. And the same with the tuple, we print the one that comes first alphabetically, and that's Craig. So that's the min. The maximum item in a sequence, again, lexicographically, and it can be done alpha or numerically, but not both. So with bug, the maximum is U, and with pig, cow, and horse, we see that pig actually comes last alphabetically, and in our tuple example, in is the last letter alphabetically. We can find the sum of items in a sequence. They have to be numeric. So if you mix in other items that are non-numeric, let's say strings or something, it's going to give you an error. So in the case of a string, we throw a string in here and we find that we print sum, you're just going to get an error. But if we have a list of numbers and we print the sum of that list, you can see we get 27. You can also do slicing. You can combine slicing to get a sum of part of the list. So if here we want to just get the last two numbers, 8 and 12, we can do -2 onward, and that gives us 20 because we're adding 8 and 12 only. And for the tuple, we have another tuple z with 4 items in it, and we add those together, we get 80. Sorting returns a new list of items in sorted order, but it returns it as a list. So here we have a string, bug. We print the sorted version of X, and what we get back is the letters basically separated and sorted as a list, elements of a list. Our list example, it sees that these are strings, it puts them in sorted order, and it returns the list in sorted order. And it's important to understand that this does not change the original list. The sorted function is not an in-place sort. It returns a new list with a sort result. And our tuple example, we have 4 names here, and we put those in sorted order, and we get Craig, Jenny, Kevin, and Nicholas. So let's say you don't want to sort by the first letter, though. You want to sort instead by the second letter. Well, you can use a lambda function to do that. I'm not going to cover lambda functions in detail in this video, but I want to make you aware that you can sort stuff either by reverse order or using some other parameter. And we do that using key equals some lambda function. And here for each item, k, you can use as an arbitrary variable named k. We're going to take the 1th item, which is the second letter. So here it's going to be E, I, E, and R. And we're going to put those in sorted order based on the second letter. And we can see those with the second letter in sorted order. If we want to get the count of items in a sequence, we can use the count function. And here we have the word hippo in a string. We're going to count the number of times the letter P appears in hippo, and we can see that the result is 2. Here I added the word cow to the list twice. So if we get the count of the word cow, we see that that also is 2. And here we just get the word count of Kevin in this list, and we can see that it's 1. And we can get the index of an item by passing in that item and asking for the index of it. And what it's going to give us is the index of the first occurrence of that item. So in the case of hippo, if we're looking for P, it's going to give us, let's see, H is 0, I is 1, the first P is 2. So we can see the result we get is 2. It stops looking after it finds the first item that matches in the sequence. And our list example, we have cow. We have 2 cows in here, and we're going to get the index of cow, and we're going to get 1 as a return value. And then for the tuple, we get the index of Jenny, and we can see that's 0, 1, 2. So unpacking of items in a sequence, we can unpack those into a number of variables. It's important that our number of variables exactly matches the length of that list or string, because if not, we're going to get an error. So here we have a list x equals pig, cow, and horse. And if we want to unpack those and assign each of these values to its own variable, we can say a, comma b, comma c equals x. And then that's basically going to put these in order, assigning them to a, b, and c. So when we print out a, b, and c now, these are each separate variables: pig, cow, and horse. So that's called unpacking. In the next lecture, we'll learn more detailed features of lists, tuples, sets, and dictionaries.